Look at this place. It's a frozen, irradiated wasteland. The ambient temperature drops to a bone-shattering -130 degrees Fahrenheit. The air is nothing but a microscopic whisper of toxic carbon dioxide. It is a silent, dead world. If you stepped outside your airlock right now, the agonizing lack of atmospheric pressure would cause the water inside your lungs, the moisture on your eyes, and the plasma in your blood to literally boil at body temperature. You would be dead in less than 2 agonizing minutes. But what if I told you that this dead rock is our ultimate future? What if humanity is not just destined to survive hiding in fragile underground glass domes, but to completely rewrite the biological and geological destiny of an entire world? To melt its ancient hidden ice, to forge a brand new atmosphere from scratch, to paint its endless, rust-red deserts green. This isn't a science fiction fantasy. This is a step-by-step planetary engineering blueprint based on the exact laws of physics, chemistry, and biology we understand today. Today, we are going to terraform Mars. Decade by decade, century by century, millennia by millennia, we are going to look at the staggering economics, the brutal, violent science, and the terrifying moral dilemmas of bringing a planetary corpse back to life. Grab your spacesuit. We've got a world to build. Chapter 1: The Anatomy of a Planetary Murder. Before we can bring Mars back to life, we must act as cosmic detectives and understand exactly how it died. Because make no mistake, Mars wasn't always this hostile, barren hellscape. 4 billion years ago, during an era scientists call the Noachian period, Mars and Earth were twins. Mars had a thick, warm, heavy atmosphere. It had raging river systems carving deep, winding canyons into the bedrock. It had a massive ocean that covered almost its entire northern hemisphere, containing more water than Earth's modern Arctic Ocean. We know this isn't just a hopeful guess. Our billion-dollar rovers, like Perseverance and Curiosity, are literally driving over ancient riverbeds inside Jezero crater right now. They are analyzing smooth, rounded riverstones and drilling into clay deposits that can only physically form in the presence of liquid, flowing water. So, what happened? Where did all the oceans go? Who killed Mars? The Sun did. You see, Mars is significantly smaller than Earth. It holds about 10% of our planet's mass. Because of this smaller size, its internal molten core cooled down incredibly fast. On Earth, our rapidly spinning molten iron core acts like a massive electromagnetic dynamo. It generates a powerful magnetic field that wraps around our planet, acting as an invisible shield against outer space. But on Mars, about 4.2 billion years ago, when the core finally cooled and froze solid, the dynamo stopped. The planetary heartbeat flatlined, and the magnetic shield completely vanished. Without a magnetic shield, Mars was left utterly defenseless. A relentless, invisible barrage of solar wind, highly charged, supersonic particles fired directly from the Sun at 1,000,000 miles per hour battered the planet. NASA's MAVEN spacecraft has actually recorded this exact process happening today. Molecule by molecule, century by century, the Sun literally blasted the Martian atmosphere away into the dark, freezing void of deep space. As the air thinned, the atmospheric pressure plummeted below the Armstrong limit. Without pressure, the vast oceans simply boiled off into space or retreated deep underground, freezing into solid, buried permafrost. Mars died. It became a freeze-dried fossil of a planet. To reverse this monumental cosmic tragedy, we have to do three impossible things. 1. Warm the planet. 2. Thicken the atmosphere and introduce breathable oxygen. 3. Build a permanent shield to protect our new creation. Let's start with phase 1. We need to turn up the heat. Chapter 2. The nuclear thermostat and the gossamer mirrors. Right now, the average surface temperature on Mars is -81 degrees Fahrenheit. During a harsh winter night at the poles, it drops to a lethal -243 degrees. To even begin the biological process of terraforming, we need to artificially trigger a massive runaway greenhouse effect. And the fastest, most violently efficient way to do that? Thermonuclear weapons. You might have heard of Elon Musk's infamous suggestion to nuke Mars. It sounds absolutely insane, the kind of thing a comic book supervillain would suggest, but there is actual, terrifyingly sound physics behind the madness. The Martian poles are covered in massive, bright white ice caps, but this isn't just water ice. The outer layers are packed with millions of tons of frozen carbon dioxide, dry ice. If we detonate high-yield fusion nuclear weapons, specifically clean Teller-Ulam design hydrogen bombs, high in the atmosphere directly above the poles, the intense flash of thermal radiation would vaporize that dry ice instantly. This dumps colossal amounts of gaseous CO2 directly into the thin air. CO2 traps the sun's heat. The planet gets slightly warmer, which naturally melts more ice, which releases more CO2, which traps even more heat. It is an unstoppable planetary chain reaction. But dropping tens of thousands of nuclear warheads on our future home is messy. Even atmospheric airbursts create some radioactive fallout, spreading isotopes across the dust. We don't want to poison the exact soil we eventually plan to farm. We need a cleaner, more elegant, and far more advanced solution. Enter the orbital megastructures. Imagine constructing gigantic, ultra-thin reflective sails in high orbit made from aluminized mylar. We are talking about mirrors hundreds of miles across, woven together by swarms of automated spider drones in zero gravity. We angle them perfectly to catch the sparse Martian sunlight and focus it directly onto the polar ice caps. It acts exactly like a giant magnifying glass burning a dry leaf on a summer day. Clean, continuous, infinite heat pouring down from the heavens, slowly melting the poles without a single drop of radiation. Meanwhile, down on the frozen surface, we deploy a completely different tactic. We build highly automated nuclear-powered chemical factories. They look like massive, brutalist fortresses. Their only job? To autonomously strip mine the Martian dirt, extract fluorine and carbon, synthesize super greenhouse gases like chlorofluorocarbons and perfluorocarbons, and belch them into the sky 24/7. These are the exact same hazardous gases we internationally banned on Earth in the 1980s because they destroyed the ozone layer and caused intense global warming. On Mars, intense global warming is exactly what we want. These super gases are 10,000 times more potent at trapping solar heat than regular CO2. Another brilliant local solution is silica aerogel. Scientists have proposed placing thin shields of aerogel, a material that is 99% air but highly insulating, over ice-rich regions. The aerogel lets sunlight in but prevents heat from escaping, creating solid-state greenhouses that melt the ice beneath them automatically, creating warm, wet oases to start planting. Within a century of this continuous, relentless industrial effort, the temperature finally hits the tipping point. The Martian equator rises above freezing during the summer days. The deep underground permafrost begins to sweat. Mars is finally warm. But here is the devastating catch. You still cannot breathe. Chapter 3: The Great Bombardment and the Asteroid Tugboats. Warming Mars isn't enough. The atmospheric pressure is still hovering at less than 1% of Earth's. If you take your helmet off, your bodily fluids will still boil. And here is where we hit a terrifying multi-trillion-dollar roadblock. In 2018, NASA published a devastating scientific study that nearly killed the terraforming dream. They calculated that even if we successfully melted every ounce of polar ice and baked every single rock on the surface of Mars to release its trapped gases, there simply isn't enough carbon dioxide left on the planet to build a thick, Earth-like atmosphere. The solar wind simply stole too much of it over 4 billion years. Best case scenario, we'd max out at about 7% of Earth's atmospheric pressure, enough to stop your blood from boiling, but not enough to sustain a massive biosphere. If Mars doesn't have the atmospheric ingredients, we have to steal them from the outer solar system. Welcome to planetary engineering on a godlike scale. We send massive fleets of heavy robotic tug ships deep into the cold dark, out past the asteroid belt, out to the frozen centaurs, and to the distant icy moons of Jupiter and Saturn. We are hunting for very specific targets, massive comets and asteroids made of pure ammonia, methane, and water ice. Why ammonia? Because it is a hyperpotent greenhouse gas, and more importantly, it is packed with nitrogen. Mars is severely starved of nitrogen. It makes up 78% of Earth's air, and without it, plants cannot grow, and humans cannot breathe safely without risking oxygen toxicity. We attach massive nuclear thermal propulsion engines, or giant electromagnetic mass drivers, to these miles-wide ice mountains. We precisely calculate orbital mechanics. We alter their trajectories over decades. And we steer them directly into a devastating collision course with Mars. The resulting impacts would be apocalyptic. Each strike hits the Martian surface at 40,000 miles per hour, exploding with the force of millions of megatons of TNT. The crust shatters. Massive, glowing craters the size of cities are formed in seconds. Gigantic shockwaves ripple across the planet, kicking up global dust storms that darken the sky for months. But with every single massive explosion, billions of tons of vital water vapor and nitrogen gas are instantly, violently vaporized into the atmosphere. We are literally physically beating the planet until it submits, bombarding it with the fundamental ingredients for life. Decade after decade, asteroid after asteroid, the atmospheric pressure slowly rises. The air gets heavy. And then, an absolute miracle happens. Dark, heavy clouds form over the red horizon. Lightning flashes across a Martian sky, illuminating the dust. And for the first time in 3 billion years, it rains. Chapter 4: The Poisoned Oceans of Oceanus Borealis. Water is the blood of a living world. As the atmosphere thickens and the torrential, relentless rains fall, the deep underground glaciers of Mars finally melt and rise to the surface. Water begins to pool in the giant impact craters, creating vast, muddy lakes in places like the Hellas Planitia Impact Basin. Ancient bone-dry canyons, like the Valles Marineris, a canyon system the length of the entire United States and 4 times deeper than the Grand Canyon, fill with raging, incredibly violent torrents of water. Gravity naturally pulls all this immense volume of water downhill directly to the vast, smooth, low-lying plains of the Northern Hemisphere. Slowly, an ocean forms, the Oceanus Borealis. It covers nearly a third of the entire planet. The sky shifts from a dusty rust red to a deep, bruised twilight blue as the newly thickened atmosphere finally scatters the sunlight in familiar ways. You could now stand on the rocky shore of a Martian beach. You wouldn't need a bulky, pressurized spacesuit anymore. The pressure is high enough. You could walk outside in regular clothes, a heavy thermal coat, and a sleek, simple oxygen mask. But if you knelt down, cupped your hands, and took a sip of that new ocean water, it would kill you in horrific agony. The Martian soil is deeply laced with high concentrations of perchlorates. These are highly toxic, highly corrosive salts that we actually use on Earth to make solid rocket fuel. They severely destroy the human thyroid gland and are instantly lethal to almost all carbon-based life. Because of this, the new Martian Ocean isn't a tropical paradise. It is a deadly, freezing, heavily acidic soup of dissolved toxins. To clean millions of cubic miles of poisoned water and to create breathable oxygen out of a suffocating carbon dioxide atmosphere, human machines and filters aren't enough. We need an army that works for free and an army that can replicate itself into the trillions. A microscopic mutant army. Chapter 5. Para-terraforming and the mutant green dawn. Before we unleash biology, human colonists need places to live during the transition phase, which will last centuries. We employ a method called para-terraforming or partial terraforming. Instead of waiting for the whole planet to be breathable, we build massive, transparent domes over craters. We span incredibly strong carbon nanotube roofing over the smaller canyons. We seal massive underground lava tubes, like those beneath the Pavonis Mons volcano, and pressurize them, building massive, glowing subterranean cities protected from radiation, while the chaotic planetary engineering happens on the surface. But outside those protected cities, the real work begins. You don't terraform a planet by planting a tree. If you planted a mighty oak tree in Martian soil right now, it would suffocate and die in seconds. You have to start at the absolute microscopic bottom of the food chain. Using advanced synthetic biology and CRISPR-Cas9 gene editing, we take extreme survival microbes from the darkest frozen wastes of Antarctica and the radioactive ruined reactors of Chernobyl. Bacteria like Deinococcus radiodurans, famously known as Conan the bacterium for its ability to survive extreme nuclear radiation, and resilient cyanobacteria. We tweak their DNA to eat toxic Martian dirt. We splice in antifreeze proteins from Arctic flounders so they survive the freezing nights. Then, using automated drone fleets, we carpet bomb the entire planet with them. These engineered extremophiles have a singular, suicidal purpose: eat the highly toxic perchlorates, digest the heavy carbon dioxide, and excrete pure oxygen. As trillions of them multiply, live and die over centuries, their microscopic bodies form a thick layer of organic sludge. Dead, toxic red dust slowly, painfully transforms into living, black, nutrient-rich soil. Once the soil is sufficiently detoxified, phase 2 begins: botanical succession. We drop seeds for genetically engineered alpine plants, tough, dark mosses, resilient lichens, and tundra grasses engineered to survive frost. They spread like a dark green rash across the equator. We design their leaves to be dark purple or black rather than light green. Why? So they absorb far more of the faint Martian sunlight, holding on to the heat and helping to warm the planet even further. Phase 3 introduces the very first complex animals. Insects, genetically modified earthworms to aggressively aerate the packed soil. Cold-resistant bees to pollinate the new, strange alien flowers. Finally, massive, genetically altered pine and redwood forests take root along the shores of the toxic oceans, acting as massive biological filters, pulling toxins from the water through their deep roots. Mars is officially biologically alive. But here is the brutal, unavoidable reality of biology. Creating a breathable oxygen atmosphere takes a painfully, excruciatingly long time. Even with the entire surface of Mars covered from pole to pole in dense, genetically hypercharged forests, it could take up to 100,000 years to naturally produce enough atmospheric oxygen for you to safely take your mask off. We might build giant, nuclear-powered, oxygen-cracking factories to speed this up, splitting water into hydrogen and oxygen. But for hundreds of generations, humans on Mars will be mask breathers. Stepping outside will always require a breathing apparatus. And worse, if we don't solve one final catastrophic physics problem, the Sun will simply strip all of this new atmosphere away, and Mars will die a second time. All of our work will be erased. Chapter 6: The Invisible Shield and the L1 Megastructure. Remember the solar wind, the relentless, invisible killer that destroyed Mars 4 billion years ago? We cannot restart the planet's molten iron core to get its natural magnetic field back. It's solid rock. The planet's heart is permanently, irreversibly stopped. So, we have to build an artificial one. NASA's Planetary Science Division has proposed a mind-bending science fiction-level solution that uses real-world physics. We don't need to wrap a massive physical shield around the entire planet of Mars. We just need to place a powerful shield in front of it. We fly millions of miles out to the Mars L1 Lagrange point. This is a precise gravitational sweet spot in deep space, directly between the Sun and Mars, where the gravity of both celestial bodies perfectly cancels each other out. An object placed here stays here, permanently locked in a stationary orbit relative to Mars. At L1, we construct a colossal helium-3 nuclear fusion-powered superconducting magnetic dipole. It is a megastructure the size of a small moon. When we power up this massive orbital ring, it generates an immense, invisible magnetic bubble that stretches for millions of miles. As the deadly supersonic solar wind hits this bubble, the plasma is forcefully deflected outward, parting around Mars exactly like a rushing river flowing around a smooth stone in a stream. Safe inside this sprawling, invisible magnetic shadow, the newly created atmosphere finally stops bleeding into deep space. The planetary bleeding is stopped. Down on the surface, the lethal cosmic radiation drops to safe, Earth-like levels. Humans can finally walk the surface without fearing radiation sickness or cancer. And this megastructure provides a breathtaking, almost poetic side effect. When the highly charged, deflected solar particles hit the edges of the magnetic bubble and interact with the extreme upper layers of the new atmosphere, they will create intense, permanent, global auroras. the Martian night sky would forever burn with twisting, majestic ribbons of green, purple, and crimson fire stretching from the North Pole all the way to the equator, a permanent, glowing reminder of human ingenuity. Chapter 7: The Quadrillion-Dollar Question and the Martian Evolution. Scientifically, physically, and biologically, we have the blueprint. We know exactly, mathematically, how to do this. But then we slam headfirst into a massive, uncompromising wall. Reality, economics, and human nature. Who is going to pay for this? Terraforming Mars doesn't cost billions. It doesn't even cost trillions. It costs quadrillions of dollars. It is an economic undertaking so vast it breaks modern capitalism. It requires space elevators made of carbon nanotubes tethered to the Martian moon Phobos. It requires massive, automated asteroid mining operations to extract platinum, gold, and rare earth metals to send back to Earth just to fund the Earth-side economy. It requires an industrial supply chain the size of a continent. But the real currency of terraforming isn't money. It's time. This project takes thousands of years. The brilliant engineers who design the orbital mirrors will die centuries before they are built. The brave humans who detonate the first polar nukes will never see the blue skies. Their great-grandchildren will never see the oceans. How do you keep Earth, a politically unstable, deeply divided planet, funding a single massive construction project for 100 generations? How does the funding survive inevitable world wars, global economic collapses, and shifting political empires? The truth is, Earth might start the project, but Mars will have to finish it, and eventually Mars will change its people, literally reshaping their biology and culture. Living in 38% gravity, future generations of children born on Mars will grow much taller, perhaps reaching 7 feet on average, with elongated spines and lighter, more fragile bone density. Gestation in the womb will be different. Their immune systems will adapt to a completely sterile, highly engineered environment. Within a few centuries, Martians will be a biologically distinct species from Earthlings. They will walk differently. They will have a different calendar, counting years in Martian sols. They will speak new dialects. Will a self-sustaining, genetically distinct offshoot of humanity, living on a fully functioning planet, want to take orders and pay heavy taxes to a world millions of miles away? History proves that colonies separated by vast oceans eventually demand independence. The American Revolution was fought over an ocean that took 2 months to cross in a wooden ship. The dark, terrifying void between Earth and Mars takes 7 months to cross in a spaceship. The red planet will become the green planet. And inevitably, through politics or through blood, it will become the free planet. Chapter 8: The Dark Dilemma, Reds versus Greens. Before we set this unstoppable planetary chain of events in motion, we have to pause. We have to look in the mirror and ask the most terrifying, deeply philosophical question of all. Should we do it? Do we, a flawed species that has already severely damaged the biosphere of our own home world, have the profound moral right to play God with another planet? This debate will fracture humanity into ideological factions. The Greens, who believe that life is precious and we have a divine or scientific mandate to spread the biosphere wherever we can. And the Reds, who believe Mars is a majestic, pristine wilderness that has a fundamental right to exist untouched by human greed. But the debate isn't just about preserving pretty rocks. What if Mars isn't totally dead? We know the surface is blasted by radiation and totally sterile, but deep underground, miles beneath the crust, in dark, warm, pressurized aquifers near the planet's dormant mantle, alien microbes might still exist right now. A second Genesis, an entirely separate tree of life, hiding in the dark, surviving for 4 billion years against all mathematical odds. If we flood the planet with water, if we drastically alter the atmosphere, and if we unleash highly aggressive, genetically modified Earth bacteria, they will inevitably seep into the groundwater through forward contamination. Earth life is aggressively, violently competitive. Our synthetic microbes will outcompete, consume, and utterly eradicate any native Martian life. We would be committing deliberate, irreversible planetary ecocide. We would destroy the greatest scientific discovery in the history of the universe, the definitive proof of alien life, just so we can have a second backyard. Do we strictly adhere to a cosmic prime directive, preserving Mars as a magnificent, silent monument of nature? Do we leave it to the microbes? Or do we have a cosmic duty to spread the light of consciousness? If Earth is struck by a rogue asteroid tomorrow, or destroyed by global nuclear war, humanity goes extinct. Terraforming Mars is the ultimate backup drive. It ensures that the spark of human life, our art, our music, and our science survives forever. Epilogue: the deep future of the human cosmos. Terraforming Mars is the ultimate test of our species. It requires us to stop thinking like tribal apes fighting over imaginary borders on a single fragile rock and start thinking like a true, unified, multi-planetary civilization. It forces us to build something that we will not live to see finished. It is the ultimate act of generational love. Perhaps it will take 1,000 years. Perhaps it will take 50,000 years of tireless, agonizing generational labor in the dark and the cold. But the physics are real, the math works, the blueprint is waiting for us. One day, far in the deep future, a human child will stand on the grassy shores of the Oceanus Borealis. They will feel a cool, wet breeze on their face. They will watch a genetically engineered bird soar overhead. They will look up into a bright, thick blue sky and see a tiny, pale blue dot shining brilliantly in the heavens. They will know that their distant, ancient ancestors came from that pale blue dot in the sky. But they will look down at the deep green grass beneath their feet. They will listen to the sound of waves crashing against the Martian shore. And they will know that they are home. The universe is a vast, cold, dark, and indifferent place. Perhaps our human destiny isn't just to quietly observe it through telescopes, waiting for the end. Perhaps our ultimate purpose is to bring the universe to life,